Today we're going to be looking at the property of logs. And so we're going to go through, we've learned how to evaluate logarithms, how to solve logarithms when there's one log on each side. Now we're going to look at some properties of logs so that we can work when there's more than one logarithm on a side. But I wanted to talk about a log where the bases match the base of a exponent. So we know that this is an exponential form. If I solve this, I would rewrite it as 7 to the x equals 7 to the third. And then x just equals 3. So what happens really is when the base of your log matches the base of an exponent, they really just cancel each other out and we just get 3 as our answer. So that's one key thing we want to, we've seen these problems and you've worked some out, but we haven't actually talked about them in class. So I wanted to make sure that we understood that concept. And if you forget it, it's not something that you can solve it on your own and figure that out. So, all right. So our goal today is that we can use property of logs for solving logarithms. And the first one is the product property. So how we multiply in logs. And multiplication in logs is addition. So we know logs are either really big numbers or really small numbers. And so that's why we use them, because when we multiply, then we add the two together. But the bases have to be equal. So when I am looking at the addition of logs, that really is 5 times 6. If this base equals this base, I could rewrite this as 5 times 6, or I could write 5 times 6 as log base 2 of 5 plus log base 2 of 6. So we can go back and forth on that. So here they give us one log number. We're going to use that to find log 250. So without a calculator, so we understand the property of logs. So if I look at 250, let's break it down into prime factors. So if I divide by 2, get 125, 5, I get 25, 5, and 5. So I could rewrite 250 as 5 to the third times 2. But we just learned that product in log is addition. So I could rewrite this product, this times 2, as log 5 to the third, plus log 5, 2. Well, log 5 to the third, since those bases are the same, that cancels out and I just get 3. And we know log 5 base 2 is this, 0.4307. So I get 3 plus 0.4307, 3.4307. So this is it. So much about this answer is that I can see through your work. So again, work's going to be important that you understand that product property, because that's going to be important when we have variables. So let's look at another one here. Log base 2 of 3 is 1.5850. So again, we're going to take 96, break it apart into prime factors. So I could rewrite this as log base 2, and 96 is 2 to the 5th times 3. But again, multiplication is addition in log. So log base 2, 2 to the 5th, plus log base 2 of 3. And these same bases cancel out and give me 5. Log base 2 of 3 is 1.5850. So I get 6.5850 as my answer. So if you understand that concept of anytime I see addition or multiplication in logs, I'm going to change it to addition, and anytime I see addition in log, I can change it to multiplication. That helps us with solving them. All right, let's look at quotient because we looked at multiplying. So quotient property of logs is subtraction. So opposite of addition is subtraction, opposite of multiplication is quotient. So if I have division, I can subtract the two, and that would be the same thing. So pH of a substance is designed as a concentration of hydrogen ions, H plus, in moles. It is given by this formula, pH equals log base 10 of 1 plus H plus. Find the amount of hydrogen in a liter of acid range that has a pH of 5.5. So I'm going to I'm looking for H here. So I'm going to put 5.5 log base 10 of 1 over H hydrogen plus hydrogen ions. And I can rewrite this because it's division as log base 10 of 1 minus log base 10 of hydrogen plus. We know that this 1 is the same as 10 to the 0 because I want to match those. So log base 10 to the 0 equals log base 10 of hydrogen ions. So this gives me just 0. Whoops, minus, sorry. So I have 0 minus log base 10 of H hydrogen ions. If I divide by that negative 1, I get negative 5.5. So we learned yesterday that when I have, I can solve for this. So I'm going to write this in exponential form. So 10 to the negative 5.5 equals hydrogen ions. So, and I plug that in to my calculator. I get 3.16 times 10 to the negative 6. All right, let's look at some more here, just so we can, for time's sake. If I have a power in log and the bases aren't the same, so it won't cancel out, the power is the same as if I wrote it in front. So it's the same as 5 times log base 2 of 6. So we're given here. So I'm going to take 216. I'm going to divide by 6 so I can, because I see that that's 6 there, so I divide by 6. 36 and 6 and 6. So I know 216 can be written as 6 to the 3rd power, and then I can put that power out front. So it'd be 3 log base 5 of 6. And log base 5 of 6 is 1.1133. So then I can multiply that. And I get 3.3399. So let's look at solving these. So using all of our methods. So we see subtraction, we should think quotient. Any numbers out front, I'm going to move to powers. So I could rewrite this as log base 2 of x to the 4th minus log base 2 of 5. Because we know how to solve these if I have just one log on one side. So we're going to try, our goal is to get that. And then we have subtraction here. So I could rewrite this log base 2 of x to the 4th over 5 equals log base 2 of 125. Now I have one log on each side, so those logs have the same base, so they drop off. And I have x to the 4th, 5 equals 125, and then I can just solve my equation. Multiply by 5. X to the 4th equals 625. Take the 4th root of both sides. X equals 5. When we plug that back in, we don't get a negative, so we check that, and that's our answer. So we're going to use those properties to get into single log. We're going to look at one more, and then I'm going to let you work. So again, we have a number in front, so that'll become a power. So I can rewrite, and this means division. So I could rewrite this as log base 3 of x minus 2 squared over 6 equals log base 3 of 150. So those will cancel out. X minus 2 squared over 6 equals 150. I'm going to get that by itself, so multiply both sides by 6. X minus 2 squared equals 900. Get rid of that squared by square rooting both sides. So x minus 2 equals 30. And then add 2. X equals 32. All right. If you have any questions, make sure you come in.